Hi everyone, in this video I will explain about combination of resistor circuits. There are three types of combination possible. One is series combination of resistance, parallel combination of resistance, and both series and parallel. Each electrical circuit consists of two or more elements. They can either be connected in two different ways, either in series or in parallel. Now the question that comes to your mind is, what is series connection or what is parallel connection? In order to have a desired value of resistance in a circuit, sometimes we have to connect two or more resistors together. This is the figure of an actual resistor. They can be combined either in series or in parallel or both in series and parallel. So when the combination of the resistance is to be increased, they are combined in series, and when the combination of the total resistance is to be decreased, then we have to combine in parallel. So we allow a heavy current to pass through it. So what is series combination? To understand this connection, consider an example of a water pump as shown in this figure. This is a water pump, connected water tank is there, and we have connected three pipes A, B and C together. Let's say you're having these three pipes and the water pump. You connect those pipes as shown in the figure. Now what will be the direction of water flow? Yes, you have guessed it right. The water will flow from pipe A to pipe B and then to pipe C and then into the tank. As you can see, there is only one flow of water throughout all the pipes, and there is an equal amount of water in all the three pipes. As you can see, the water flows from pipe A, pipe B, pipe C, and equal amount of water is flowing. The direction of water will be pipe A, then through pipe B, and then through pipe C. So this is the direction, and what happens? Equal amount of water flows. So if you have understood this, then you have understood what is series connection. So unlike water, what we have used here, current is flowing, and unlike the three pipes, I have taken the resistors R1, R2 and R3. And instead of pump, I have used a battery. So this is an example of series connection. What we saw, that the same amount of water flows through the three pipes. So here in series connection, the same amount of current flows through resistor 1, resistor 2 and resistor 3. What about voltage? The voltage gets divided. There is a voltage drop across R1, resistor R1. There is a voltage drop across resistor R2, and there is a voltage drop across resistor R3. So what is series connection basically? When one end of a resistor is connected to a battery and the other end is connected to the another end of a resistor. So when basically the ends of a resistor are connected together, then it is said to be in series. Suppose, let's see, the voltage here at the point A be VA. Let me write it here. VA, the voltage at point A is VA. The voltage at point B, or the potential at point B, let it be VB. The potential at point C, let it be VC. And the potential at point D, let it be VD. So since the positive potential of the battery is connected to the point A, so VA is maximum. And since the negative terminal of the battery is connected through the key to the point D, the VD is minimum. And what we should always remember, since there is a resistor here, the current will be flowing, but the voltage or the potential is decreased. The potential at VA is maximum, the potential at VB is decreased, then VC is again decreased, and at point D it is the minimum. So we can write VA is the maximum, then VB, then VC, then VD. And what we studied in this diagram, that water flows in equal quantity. So here what happens? Current is always same. Current is same throughout the circuit, right? Throughout the circuit. So I is flowing through R1, same I flows through R2, and same I flows through R3, and the same I flows through the battery, right? So I remains same. Current I remains same. So let's calculate what is the voltage drop across R1. How can we calculate a voltage drop? Voltage drop is the difference between high potential of the resistor and the low potential of the resistor. So what is the voltage drop across R1? Can be written as VA minus VB. This is the voltage drop across R1, and that can be what? Voltage drop is what? Formula is V is equal to IR. I flowing through it is same current I, and what is the resistance here? R1. Similarly, voltage drop across R2 will be VB minus VC, that is equal to IR2 according to Ohm's law. Then voltage drop across R3 will be VC minus VD, that is equal to IR3. Now let's consider what is the total voltage drop between, what is the voltage difference between point A and point D. So we can write what is the voltage difference between point A and point D, can be written as point A voltage at potential at point A minus potential at point D, right? That can be written as I into the total resistance. Let me write the total resistance as RS, equivalent resistance when connected in series. So what will be become? I into RS, that is equivalent resistance when connected, all the resistors are connected in series, is equal to what? VA minus VD is equal to voltage drop across R1 plus voltage drop across R2, voltage drop across R1 plus voltage drop across R2 plus voltage drop across R3, right? So what we can write this equation as combining all the resistances together and taking out I as common, we can write like this. So cancelling out all the I on both sides, what we can write? RS is equal to R1 plus R2 plus R3. So we found out whenever we connect resistors in series, or whenever the resistances are connected end to end by side, then the equivalent resistance is equal to the sum of resistors together. From this we get this formula, that whenever the connection is made in series, the equivalent resistance is equal to the sum of resistance connected together. So let's see this example. What is the magical thing in series connection? So we already have studied that current flowing through the series resistance has only one path to flow, or the same current flows through all the resistors when connected in series. Now let's see this example. There is a voltage or a battery given of 9 volt, and we have three resistors R1, R2, R3 of 3, 10 and 5 kilo ohms. So what will be the R total, RS, or when connected in series, what will be the total resistance? Sum of the resistance. So it comes to 18 ohm. Now how can we calculate current? Current is V by R according to Ohm's law, and V is given here 9 volt. So V by, and total resistance we have calculated as 18 ohm. So what is I? I comes as 0.5 milliampere. Now this 0.5 milliampere is same throughout R1, R2 and R3. right? In series current, same in series connection, same current flows throughout the circuit. So what will be the voltage drop across 3 ohm resistor? Again, I into R, that is 0.5 into 3. So this comes as 0.5 volt. Similarly, voltage drop across 10 ohm is 5 volt. Voltage drop across 5 ohm is 2.5 volt. Adding all these 3 volts, what we can see, voltage drop comes to 9 volt, which is nothing but our source voltage. So we can see from this connection that what happens, the source voltage is equal to voltage drop across R1 plus voltage drop across R2 plus voltage drop across R3. So this is the magical thing in series connection. Now what are the points we have to remember? We already know that current has only one direction to flow. Voltage is different across different components. Then the total source voltage is always equal to the voltage drop across the resistors. Then what happens? In series, we always add the resistors. Then where are these series connection used? It is used where voltage division is needed. Why? Because the total voltage is always equal to the voltage drop across the resistors. Then in reactor of power systems. Then in logical wiring where multiple conditions are checked. Now what is parallel connection? In order to understand this parallel connection, I have connected the pipes in this way. In this case, how will be the direction of water flow? Let's check. The water will start from pipe A and then it gets divided in the two branches and then comes back together. So what happens here, as you can see, there are multiple flow of water in this type of connection and the quantity of water is different in each pipe depending on the size of pipe. So this is nothing but a parallel combination. If you have understood this diagram, then you have understood 50% of the stuff. So let's see this figure. Unlike the pipes, here I have connected the resistors. And unlike the pump, we have given a battery. And what happens to the current shows the direction of water flow. What happens? The current flows and then it gets divided at the different branches. So this is a parallel combination. And when they are connected in parallel, the equivalent parallel resistance can be calculated by this formula. So how is this formula came? How this formula came? So let's see. Let's understand how it came. So let's say the voltage at point A be VA. The voltage at point B be VB. And since point A is connected to the positive terminal, VA is maximum and VA is connected to the negative terminal, so it is minimum. And what will be the voltage drop across VA between voltage drop across R? It will be VA minus VB, right? Voltage drop across R. Or the potential difference between point A and point B will be VA minus VB. Similarly, the voltage drop across R2 will be same, VA minus VB. What will be the voltage drop across R3? Same, it's VA minus VB. So what we can see from here is that all the voltage drop across R1, R2 and R3 is same, VA minus VB is same. VA minus VB is how much? It's the same, that is voltage given at the battery. So the voltage supplied to all the branches of resistor when connected in parallel remains same. In series, what we saw, current through each resistor remains same. In parallel, the voltage flowing through each resistor remains same. Which gets divided? The current is getting divided in the three resistors, but the voltage remains same. and the current depends upon the resistor value. Why? Because we know V is equal to IR. If the resistor is high, the current flowing through that branch will be less. If the resistance is low, then the current flowing will be high. So the current flowing through this resistor R1 depends upon the value of R1. Now let's see how this formula came. Now what we know, the total current is getting divided. I is equal to I1 plus I2 plus I3 in this figure. So we can write as what? What is I? It's V by Rp. Rp is the total resistance when connected in parallel. So what is I1? How much current flows through I1? That is V. V is the voltage. As I have shown you that V flows through R1. And what will be the resistance? R1. Now similarly, what will be the current I2? V by R2. What will be the current I3? V by R3. Now we taking common V outside, 1 into Rp is equal to V 1 by R1 plus 1 by R2 plus 1 by R 1 by R3. So from this we get this formula. 1 by Rp is equal to 1 by R1 plus 1 by R2, 1 by R3 plus 1 by Rn. So when n number of resistors are connected in parallel, we can calculate the equivalent resistance by this formula. Suppose, let's say we have only two resistors connected in parallel. Only R1 and R2 are connected in parallel. So what will be the equivalent resistance here? 1 by Rp is equal to 1 by R1 plus 1 by R2. That comes to what? R1, R2, R1 plus R2 is equal to 1 by Rp. Then what will be Rp? Rp is equal to R1, R2 by R1 plus R2. Got it? So when two resistors are connected, so this can be the formula. And we can calculate when n number of resistors are connected in parallel, we can calculate by this formula. Suppose let's say when all resistances are equal, or n resistances are connected and they are all equal, then what we can write? 1 by Rp is equal to 1 by R plus 1 by R plus dot 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 1 by R, right? That comes to 1 by Rp is equal to, if n number of resistors are connected, then n by R, right? So what becomes Rp becomes how much? Rp becomes R by N when all the resistances are equal. So let's see an example. What is the magical property of parallel connection? As you can see in this figure, there is a voltage which is connected as 9 volt, then 3 resistors of different values. So how can we calculate the current? Current is always V by R1 and it comes to 0.9 milliampere, or I1 is the current flowing through R1, I1. The current flowing through R2 is I2 and it has come 4.5 milliampere. Similarly, current through R3 is I3 and it comes to 9 milliampere. So when we add the total current is I1 plus I2 plus I3, it comes to 14.4 milliampere. Now how can we calculate the total resistance, it is always voltage by current. So 9 is the voltage, V is 9 volt, and what? And the current is 14.4, that comes to 0.625 kilo. Here we have observed that the total resistance of the circuit, total resistance is how much? 0.625 kilo ohm, is very low compared to the individual resistors. Individual resistors, the lowest one is 1 kilo ohm, but the total equivalent resistance is 0.6. So the resistance value is very low, total resistance value is very low in case of parallel connection. So this is a magical property of parallel connection. This is one way of finding out the resistance when connected in parallel, total resistance. What is the another formula that we have studied? 1 by Rp is equal to 1 by R1. I am writing directly 1 by 10 plus 1 by 2 plus 1 by R3 is 1 by 1. That comes to how much? Taking 10 as the LCM, you have 1 plus 5 plus how much I can write? 1 tens are, so 10. So it comes to 16 by 10. That is 1 by Rp. So Rp is how much? 10 by 16. That comes to 0.625 kilo ohm. So this is a better way of finding the resistance, total resistance when connected in parallel. Now what are the points we have to remember? That the voltage remains always same throughout the resistor. Current has multiple paths. Total resistance decrease in parallel connection. Total current is always equal to the sum of individual current. Now biggest application of parallel combination is the wiring in our homes. Generally we prefer parallel combination over series. Why? We will study it. Now there is another combination possible, that is combination of resistors both in series and parallel. As you can see in this figure, we have one series resistor and another one is parallel combination, but both is possible in one circuit. Suppose we have three resistors. Suppose you have three resistors and each one is of 1 ohm value, but you want the total resistance or total equivalent resistance of the circuit should be 1.5 ohm. So how you can connect? You can connect in this way. So what will be the total equivalent circuit of this one, of parallel combination? I can write as 1 by Rp is equal to 1 by R1 plus 1 by R2. That comes to how much? It comes to 1 plus 1, that is 2. So 1 by, sorry, Rp becomes how much? 1 by 2, that is equal to 0.5. So the total combination of this one comes to 0.5. Now what happens? Let me redraw this circuit as like this. This one is 0.5. We have already calculated 1 and 1 when in parallel. Then another one is in series. 1 ohm is in series. So what will be the equivalent resistance of this one? Equivalent resistance Rs is equal to 0.5 plus 1 ohm. That comes to 1.5 ohm. So when we need a desired value of resistance, then we can combine both the circuit in parallel as well as in series. So I was telling you that why we always prefer parallel combination over series. Let's see this diagram. As you can see here, there is one resistance or resistor given. This is an actual resistor, but which is connected in series here? The resistor is also connected in series with the LED, but the LEDs are connected side by side. So the resistor is connected with LEDs and these are in series. Suppose, and when we have connected a battery, what happens? Current flows through it. It becomes a closed circuit and current flows through it. And when the current flows through the LED, these are all lit up. But suppose we take out, or one LED doesn't work and it is being taken out. Now what happens to the whole circuit? Even though the red LED and the yellow LED is in good working condition, still when one is not working, the whole circuit stops functioning. So let's see what happens in parallel combination. In parallel combination, once the battery is attached, and here what we have placed 3 LEDs in parallel, right? When the battery is attached, current starts flowing. What happens? There is a current flowing through I, and it gets divided here I1, here I2, and here I3 flows. And what happened when current flows through this all circuits? All the LEDs are lit up. But suppose this green one gets bad or is not working, it's malfunction. So what we did, we took out that one. But what happens in a parallel connection is current is flowing through the red and yellow. It keeps on giving us light. In here, the whole circuit is not closed down. Here, even though one LED is not working, the other two keeps on working. So this is the advantage of parallel combination. If one circuit or one LED or one electrical component is not working, it doesn't affect the work of others. So we prefer parallel combination over series. I hope you have understood parallel combination and series combination. Thank you for watching my video. If you like my video, please subscribe to my channel and give a like.